Hello, good morning, and welcome to you all to my presentation today. In the last class, we have discussed about proxy indicators, which are used for construction of the past climates. We have discussed about also few of the causes or sources of the climate variability or climate change, and we have discussed in that cases we have discussed about two important internal mechanism. One is Atlantic oscillation, and another one is Southern Pacific oscillation, El Nina or La Nina. So today we are going to discuss about two other internal mechanism. So one is Atlantic multi-decadal oscillation, another is Pacific decadal oscillation. So before we going that, just to remind you, so we were starting to discuss about possible causes of the climate change, and there are three parts of these possible climate change causes. One is internal mechanism, which is relation to between the energy balance among the components of the environment, ocean to atmosphere or land to atmosphere, like this. We are also try to discuss in today about the external forcing. That means they are coming from other sources, and those sources can be natural and can be from the anthropogenic sources. And third of all, we'll also try to discuss a little bit about the feedback mechanism. That means which can also influence other system. So these three causes actually the basic causes of the climate changes. But the interesting thing is we are not discussing much of the internal mechanism or natural drivers. Normally we do describe or try to understand about the anthropogenic drivers, because anthropogenic causes are the main causes of the climate change nowadays, which can be regulated, or which can be modified, or we can control, whatever you can say. So that's why we are trying to discuss about the anthropogenic drivers. If we will try to understand about the natural drivers, so that we can know the science behind the climate change. But natural drivers cannot be changed or regulated by our activities. Similarly, internal mechanism, most of the cases it is not well understood by of the real causes behind that. But we can know the mechanisms, what will happen, how will happen, but we don't know the actual basic causes behind that. All we know about this is the energy balance that causes these internal mechanisms. So in the last day we discussed two of the internal mechanisms. Today we're going to discuss first of all another two internal mechanisms. Then we'll try to discuss about external forcing, natural drivers, and then anthropogenic drivers. Let's start about that. So Atlantic multidecadal oscillation is a oscillation. That means again it is a cycle that is in the that says in the that can be seen in the North Atlantic Ocean. And there is two phases in there. One is positive phases, another in negative phases. In the positive phases, we can see in this graph that the average surface temperature that has been increased in a decadal basis. You can see a long gap, 1860 to 1880, all these years. This is positively shows the mean temperature in the North Atlantic Ocean. That means 0.01. Maybe you can also ask me, it is not too much change. 0.01, it's not too much. Actually, it's not the day-to-day temperature. It's an average temperature that has been increased on the surface of the ocean. And we know ocean is a place where a huge amount of the water can store the heat. That means 0.01 degree centigrade temperature. It is also huge when you comprises this at a very large scale. That means full of the Atlantic oceans. And that's why they have much more influence. When this energy wanted to be released to the atmosphere, then it causes many important impacts, such as rainfalls, hurricanes, cyclones. Many important disasters matters can be found from these AMO. Atlantic multi-decadal oscillation. And this is also says that the circulation pattern of this temperature, which is also related to thermohaline circulation. That means with the salinity, it can be changed ups and downs after a certain decades. This is the circulation, thermohaline circulation. When it moves to the in any direction, this can be shown in different ways. So before we are starting that, let's see the impact and how it has been happened. Let's see the process with a video so that we can conclude it much more differently. Let's see. Let's see this one. So this is the Atlantic Ocean, and here is the Europe, and here is the in the downward here are the Africa, and here is North America and South America, Mexico and West Indies in there. You can see this is the temperature of the positive phases that has been showed in red colors. That means the temperature has been little bit increases within a long period of time. And this long period, you can see over a period of approximately 70 years sometimes. That means every 70 years it can be go very high and low, and that's why it is very minute, 0.01, 0.1. So that means the whole area has been warmed up for a couple of long times. And then what happened, you see, this is southern Atlantic, and this is Pacific Ocean. So according to that temperature, it is much more higher. This shows in different colors. This can have impact on the cyclone formation because high temperature is one of the basic component to grows cyclones. So this can also trigger cyclones or hurricanes. This can also increases the precipitation in many areas, northern Europe and African Sahel. Sahel is a place of desert areas, so drought African areas also increases the precipitation in that particular time, and also it can be have different impacts also. So you see, Atlantic Ocean that also triggered the wetter Indian summer monsoon. That means in Indian subcontinent also have influence from long away from the Atlantic. That also been influenced the summer rain in here, monsoon. Now you can see this is the negative phase where the surface temperature is dark blue. By the side of that one, they are not dark blue, they're little bit blue. So the average temperature has been dropped down in here. So one of the biggest causes is that includes the drier condition. So when there is much more colder time, that time that most of the areas is dried up. So this is the Sahel desert where the people also very much impacted due to less amount of the rainfall. So Sahel is a large area which is dependent on much more the AMO impact from long away. if you see this graph, you can see from 1980, it is the highest level where it started, and from long away from 1910, so almost it is 30 years. So all these 30 years, the highest level of the temperature that has been going to downward, and this is 0.25 degree that increases from here to here, and then again downward. So all these areas are said by the as a positive AMO, because this is average temperature and this is much more higher. On the other hand, even it is going down or going high, all these ways, this is also told as negative phases, because with these negative phases, the temperature has going downward from the general average. So the process is, the oscillation is going on always, and this oscillation is a coming back period, that is after a certain period they can come back again. So after 30 or 40 years they come back again. So that's why it is very important for a long time it's remain hot, remain heated up, or maybe cool down. So that has much more impact on different environmental conditions. So this is all about the circulation AMO. Now we're going to discuss about another one, and maybe it would be better to uh, let's see the first AMO. So AMO, after AMO, it is very important. Then we are also important that Pacific decadal oscillation. Pacific decadal oscillation also is a phenomena regard in the Pacific Ocean. So we discuss about El Nina and La Nina, but El Nina and La Nina, the same aspects but differently explained, because in El Nina and La Nina, that time it was happened within couple of years after, maybe 5 to 6 years time period, or at best 10 years. So within that time, it's come back again. On the other hand, Pacific decadal oscillation, it takes long time to come back, regain its strength, perhaps 20 to 30 years, but the impact is same. So why it is so different than El Nino, La Nina? It is not differently as it to look at, but the influence is much more greater, because the warming phase and the colder phase, they are in a circular positions, that after certain times it can be happen, and within all these years the warming phases is working on and the colder phases is working on, and this has a good impact on the global or regional basis. That's why it is also very important. Let's see.
The Pacific Decadal Oscillation. The Pacific Decadal Oscillation, or PDO for short, is a term used to explain climatic events which cover vast areas of the Pacific Ocean over periods of 20 to 30 years. The PDO has positive and negative phases. In its positive or warm phase, higher than normal sea surface temperatures are found stretching from the western coast of North America down to the equator. These high temperatures produce a horseshoe-shaped pattern, which surrounds a core of cooler surface waters in the central and northwestern Pacific. These warmer surface waters can result in bountiful salmon supplies in southern Alaska. In the PDO's negative or cool phase, this pattern is reversed. Cooler sea surface temperatures in the horseshoe surround a core of warmer waters. Cold PDO events have been linked to severe droughts spanning many years in southwestern USA and increased rainfall over eastern Australia. During a positive or warm phase, sea surface temperature patterns are similar to those seen during an El Nino event. However, the PDO extends much further northwards and is prominent along the western coast of North America. During a negative or cold phase of the PDO, sea surface temperature patterns are similar to a La Nina event, but again extend further northwards in the expected horseshoe pattern. And much like El Nino and La Nina, the PDO can influence weather events and global average temperatures. Positive phases of the PDO tend to be associated with periods of more rapid global warming, while negative phases can be linked to times of slower warming. This is because cold phases tend to increase mixing of colder, deep ocean waters with warmer surface waters. And this is enough to temporarily reduce the rate of global warming caused by increased greenhouse gas emissions. Warm phases have the opposite effect. The cause of changes in the PDO may be due to a combination of factors, including long-lasting fingerprints of El Nino and La Nina events, changes in atmospheric pressure in the northern Pacific, the impact of industrial pollution, and natural variability. This important phenomenon continues to be a subject of ongoing research.
So they say this is a ongoing research research matter that can be found that it is still under investigation. So it's not very well established that why it has been happened, but we know the impact of these two phenomena. That's why it is a very important discussion matter in climate change pattern. So before I starting the next level, that means external forcing, if you have any question regarding the internal mechanism or today's lecture, you can ask me if you have any question. Okay, so no question. Let's discuss about the external forcing. External forcing is a force that is coming from the outside to trigger the climate variability or climate change. So we can divide it into two parts. One is natural drivers, another is anthropogenic drivers. Natural drivers include those factors that is fully natural and we don't have any hand, and that particular change is caused by the nature itself, and there is no relationship between the anthropogenic influence on those drivers. Such natural drivers include orbital changes or the Milankovitch cycle, or solar variability changes, and also volcanic eruptions. Let's discuss a little bit about those things. First of all, orbital changes. So Milankovitch, we normally do say this is a Milankovitch orbital changes. Milankovitch is a scientist from a Serbia or in 1920, and he described that that a very long time scale changes of the orbits. So before we understand it, we should understand three basic things. One is our world is moving in a orbit, and we think this is a very constant part so that it cannot change its pathways. This is one. And this needs to circulate or to complete a cycle for 365 5 days, more or less. And then our axis, on its axis, this Earth also move around its own axis. That means the day and night, which is formed due to the circulation of the Earth from its own axis. This is another circulation pattern, and we think that this is also very constant because this also gives us a particular time period for every time. And then there is another thing that our Earth is not very the north and south pole, which is normally we do say this is very straight and forward, but actually our Earth is a little bit tilted up, and then this inclination of a certain areas that is also in that way our Earth is moving. It is not meant to be that this is very 90-degree angle between the very vertical line around an axis. So that's why the inclination is another thing. So these three things normally we do expect that this is very constant, and actually in a very shorter period this is very constant. But Milankovitch, the scientist, said that these changes is not constant. So during the movement of the orbits of the axis, these areas, which is needed 365 days to follow. So Milankovitch said in every 1000 years or more than that, this can be possible that this whole circle can be little bit changes. And we know this is an elliptical cycle, and they can be little bit change their positions after 1000 years, and again after 1000 years, with this all the way they can come back again its real pathway. So these changes also causes the amount of the sunlight that can be come to the atmosphere of the earth. So in a long run, this can also impact us. We called it eccentricity. So this is eccentricity. You can see after this is going up, down, and a constant things. So although this is changing, this is although not constant, but we do neglect it because it is going on and come back again and a very long time basis, long time period after. Secondly, when the earth moves on its own axis, that time also we think that the movement is very constant. But Milankovitch said that this is also not constant because this can also be changed after 1000 years, with this whole long time period, so that it can come back again its real position another 1000 years after. So we called it actually precession, and precessions is also can be seen from this graph that they can also come back its again its own positions after certain years. And third one is inclination or tilt. We do say obliquity. This obliquity is also important because we do have an angle every time, but this angle can also be changed. So why these three things is important? Because each of them, they can contribute the amount of the sunlight that can penetrate to the atmosphere of the sun or atmosphere of the earth. And that's why it is very important to have what amount of the sunlight that can be penetrate to the atmosphere of the earth surface. So these three things is very important for climate variability. So this is we called orbital changes. The next one is solar variability. Solar variability means the solar system. We know the solar or the rays that is coming from the sun, that is constant, and after a certain time, after each of the times we are getting this energy very constant, and normally it is 366 watt per meter square. But scientists proved that each of the 5 years, this is also little bit changes and come back again its own positions. So if you think 366 is constant in here, you can see from 1975 it started from here, maybe 1365.5, and all the 5 years it goes to here, so that it is 1366.5. So all these 5 years it increases 1 watt per meter square. So 1 watt per meter square is not too small, it's high, it's quite large. But the very general thing is we need not to taking care of it, because after that it again going to lose. So all the 5 years it again loses from 366.5 to 365.5, and again it increases. So they also make some cycle, so we call solar cycle variations, and this is remaining for a long time, and we don't have any hand or active role to control it. So that's why solar cycle variation is also very important and natural drivers. Third one is volcanic eruption. Volcanic eruption is a process by which we know a large quantity of ashes that can be found in the atmosphere in a local basis. That means in a regional basis. In the regional basis, after the volcanic eruptions, the whole sky can be covered up with ashes, and that also creates some barrier to come the sunlight to the earth surface, and actually that creates much of the cooler positions in a particular regional areas in couple of days, or maybe long time, when the ashes remain in the sky, the sunlight cannot come, and the area is most of the time it is remaining cool, and after a sudden volcanic eruptions. So these are the natural drivers which can be as a used as an external force of climate change. But normally when we are discussing in our climate change matters, we don't discuss it. So maybe the question is why we cannot discuss it. We cannot discuss it because we cannot change it, because this is come back again and regain its strength again. So it, when it is in a positive role playing, and after certain years it can again go back, so we need not to think about much of that particular phenomena, because it's not an increasing trend that it will be increased for long time. It might not be possible. Now we are very much interested about the anthropogenic drivers. Let's discuss about those things. See these graphs. This is carbon dioxide, this is nitrous oxide, this is methane, and that is sulfur. So all of them, there is a good relationship. You can see this is, first of all, this is very horizontal line. That means all the way from long 1000 to the up to 850, all the things are very normal. That means in a horizontal positions, and after 1850 there is a sharp inclination of the carbon dioxide, and it is almost nowadays 400 ppm. Similarly, all of the other graphs, they also shows the same pattern from, first of all, very horizontal movement, and then after horizontal movement in 1850 it has been increasing day by day. So why this is from 1850? Why not it is some later or after? Because these are the gases that is, most of them are coming from the industrial sources, or we can say burning of the fossil fuels and many other important environmental activities, sorry, industrial activities. And that's why after 1850, after the industrial revolution, it has been seen very sharply to increase the concentration of these gases. And these all gases are said to that they are greenhouse gases. So according to the scientists, these gases are the main culprits for the climate change, or we can say global warming. And and we don't discuss much of the other things, because these things are controlled by the human being activities. We are doing we are every day we are burning fossil fuels, and that increases the carbon dioxide. We do go for vehicle and different other industrial purposes, that increases the nitrous oxide and sulfur dioxide and sulfur related concentration. And then we also do agriculture and livestock practices throughout our world, and that's why methane is related to that. So all these activities are directly coming from the human activities. That's why we are saying these anthropogenic changes are the main causes of the climate change. But actually it is not. Actually the all of these causes trigger the climate variability or climate changes. But we are interested about anthropogenic drivers because they are sharp increase of 1850 to 1000. Many of the sorry from 1850 to 1900 1850 to 2000 2000. See all the ways this is a curve sharply increases its positions. So that's why it is also important to know that why this is important for our global warming. You can see the concentration, with the increasing of the concentration, the watt per meter square, that means the radiative force is also been changing, and that's why it is directly related to one another. If we don't have relationship between any temperature variation with the carbon dioxide or other greenhouse gas increasing, so we do not blame them. but the problem is they are directly related with that. Let's discuss about what do you mean by global warming, or what do you mean by greenhouse gas impact. Think about some of the countries, cold countries, who uses the greenhouse gases. The mechanism is greenhouse gases are the glass house. This is a glass house in cold countries where the farmers they try to cultivate their products inside, because the surrounding environment is much colder than inside temperature. What is the mechanism? Mechanism is, we know the visible light that is coming from the sun, their wavelength is much more smaller. On the other hand, when it fall directly on the ground, they turn to light energy to the heat energy, and the wavelength of the heat energy much more bigger than the light energy. So when the sunlight come through the glasses, it fall on the ground or on the surface of the vegetation, and it changes to the heat energy. And that heat energy, when wanted to go back, that time that glass, which allowed the visible light, they don't now allow the heat energy. So that is the main theme by which the increasing of the temperature is possible inside a glass house. And with that type of mechanism, people love to grow their products in the cold countries. Similarly, if you think the whole world as a greenhouse and the glasses are the atmosphere, then what happened? Then those are the light energy that is directly come from the atmosphere to the to the ground surface. We do found this, then this light energy, and then it fall on different materials. Maybe sometime it's fall on the uh, road systems, sometimes it is fall on the water system, then sometimes it is on agricultural field, vegetation cover, or anywhere it can fall. And whatever the places it fall, but it turned to heat energy, and then it's wanted to go back. And finally that has been obstacled or barriered by the create barrier by those greenhouse gases. These gases causes the feedback go back of this energy to the atmosphere. So what happened? It remains inside the atmosphere. That means the world is temperature of the world is increasing. This is how it is related to greenhouse gases. And that's why we said these gases are greenhouse gases, and these gases are the main things that we need to control to reduce our temperature. So how it has been increased? So normally we do believe that our temperature of the world should be 15 degrees centigrade on an average. Sometimes it is a much more colder in a minus temperature in the cold countries, or even in the Arctic and Antarctica. On the other hand, some of the areas like desert areas and many areas, the temperature is greater in a positions more than 40 degrees centigrade, but the average condition should be 15 degrees centigrade average. And now when this greenhouse gas are reacting in the atmosphere, the whole the average condition has little bit warming up because of these gases, because of these anthropogenic causes. And that causes the increases because carbon dioxide ppm is now maybe the concentration is 400 ppm. And with all these concentration, the radiative force also increasing in many folds, and thus this is directly related to the impact of the climate change in many areas. So if you see this one, so carbon dioxide has been increases, and the solar radiation, which normally every day come to the earth surface, they should every day go back, come from the sun, from the land surface, that should go back. But when the carbon dioxide came here, that time much of the heat they cannot go back, so that some of them remain. And these some of them remain that actually causes the warming up of the environment. So is can you understand it what I am describing? Do you have any question regarding anthropogenic causes?
Sir, I didn't understand this part, sir.
No, no, don't see this when you don't these things. What I am asking about the human activities, about greenhouse gases and how it increases the temperature. Do you understand that?
Yes, sir.
Anyone else? Do you have any question regarding anthropogenic causes? Well, so if you have no question, then I should make our for some of the other issues regarding this. Another issue is related to human activities is deforestation or the changes of the land uses. So land use is an important factor because some of the areas that can reflect the energy very nice, and some of the areas which can also absorb the energy very nicely. So when it is absorbed, that means it can heat it up the places very nicely. On the other hand, when it's reflect, that most of the energy has been lost and that can go back from some of the areas. So land use pattern change also influence that. And one of the important land use pattern is to deforestation, and deforestation is much more important because when you deforest the area, that means you are actually trying to take the carbon content which is stored inside the body of the trees that has been released now. As you are cutting down the trees, that means you are using those things. Maybe at present context, some of the trees you may not use because you can use it for different other purposes, but actually it will gonna anyway be ruined, and after some days you'll gonna burn it. And when you burn it, that means the carbon dioxide releases from those particular trees to the atmosphere. This is very important. Another thing is when you releases it, it actually creates a multiple impact. For example, water or water vapor is an important greenhouse gases, but the cloud itself act different ways inside the atmosphere. So that's why we say this is a feedback mechanism. Just to see this, external forcing activate is feedback mechanism. So how it gonna work? When we go for a particular cloud system, we will see that some of the energy which is coming from the sun, they fall on the clouds, and the clouds do not allow the energy come inside. So they have been reflected, or sometimes they have been absorbed inside the clouds and go back again. On the other hand, those energy which fall on the ground, they want, when they wanted to go back, that time the cloud says no, you cannot go. So cloud creates some barrier, and that's how the temperature remain inside the earth surface, and they are making the warming up, trying to warming up the environment. So the cloud can act both positively and negatively for the climate change sources or climate change issues. Okay, so we called it feedback mechanism because feedback is something where the act is somewhere and they can impact it onto others. That is the feedback mechanism. So if we see this curve, the analysis is much more easier because this is an important, there is an important name also, these curves. If it says only the temperature, in that time we say sometimes we say this is the shape of a hockey stick. So this is a hockey stick curve also itself. And many of the persons, they also make future future scenarios that also shows like this type of curve. So my question is why we are not worried about the other factors rather than the only, why we are yeah, making our concentration on only the anthropogenic drivers. The answer is these anthropogenic drivers are those kind of works that is governed by the human activities, and we, if we take some measures, we can control it, as we do not have any hand on the external forcing. That means any natural drivers. So do you have now any question regarding climate change? If you have any question, you can raise your voice. The next topic is impacts of the global warming or the climate change on different coastal and wetland environment. Actually, the global warming or the climate change impact can be happened in many sectors throughout the world, and each of the ecosystem that has been impacted by the global warming. But here the topic is only the coastal and wetlands. So we will gonna discuss about some water, global water cycle first, and then we'll see what are the impacts in there. First of all, how we can know what amount of the changes will come in future? Well, that can be easily understood by different models. Okay, I described what does model means before, and you can understand now. We have many logics, and depending on those logics we can expect, well, in 2050 or 2080 or 2100, this much temperature will be happen, this much precipitation will be happen. We can say that depending on our model outputs. And before, the models was named differently. Now the models in the fifth assessment report, it has been described as RCP. So four different RCPs, 2.6, 8.5, and many are another two. These four types of models, they can describe the future scenarios of the world. And from that scenario, we can, if it is happened, then what are the different sectors that will gonna impact it, that has been discussed here. So first of all, global water cycle. So if you wanted to know what would be the contribution of the global warming on the global water cycle, there is no straightforward answer. All we can say, the regions will be affected. Precipitation between wet and dry regions will be affected, because some of the areas which is much more drier in condition, they will remain much more drier condition. And some of the areas, some of the area where the precipitation is happening, maybe more precipitation will happen with the particular season, rather than the rest of them will be in drying condition in here. On the other hand, this also triggered the global water cycle, because when it has been impacted, the other process will also be impacted. Secondly, the ocean warming things. So ocean on the top of the surface, that will gonna warming up. And what is the impact if it will be warming up? There are many impacts. One of the most important thing is, if that average temperature increase little bit, if it is increases, then it will gonna also help to increase some of the chemical mechanism inside the ocean, and many things will gonna change because of these little bit temperature increase. So according to RCP 2.6, RCP means RCP is a name of the model. At it means representative representative fractional representative concentration pathways. RCP means representative concentration pathways, and there are four different pathways that can be seen in IPCC fifth assessment report. And according to them, RCP 2.6, they say it will gonna increase 0.6 degree temperature in 21st century. Now the question is it the outcome of the others? No, other models says different. For example, RCP 8.5, they said 2 degrees centigrade will be increased. Okay, so 2 degree centigrade will be increased, and that is from two different models. Okay, 2 degree and 0.6 degree. If the temperature increases, what would happen? That is another thing. But the model also try to find out what would be the inside condition of the ocean. Despite in after 1 kilometer inside of the ocean, the RCP 2.6 2.6 said it will be 0.3 degrees centigrade. That is increasing trend, and also 0.6 degrees centigrade said by the RCP 8.5. So whatever the cases, we can see the increasing trend, and this increasing trend is not good, because whether it may be changed little bit, but for a long time it can create many big problems. It has also impact on AMOS, Atlantic Meridional waterline circulation, that is also be weakened due to over the 21st century. So there are many best estimates, and according to some estimates, they said in a low confidence in assessing the evaluation of the AMOs beyond the 21st century because of the limited number of the analysis and equivocal results. So the total concentration of the increases of the global warming has impact on the AMOS time period and AMOS strength and everything. The global ocean will also continue to warming up until 21st century, and heat will penetrate from the surface to the deep ocean and affect ocean circulation. It is also said that some of the areas like Arctic Sea cover will confirmly, or we can say very likely, that will gonna be in a position of the shrinkage, because high amount of the temperature will trigger the melting of the ice, and the global glacier volume will be decreased because of this condition. Before I going there, just make you understand that what if that will happen, what would be the impact if the Arctic Sea will lose its total amount, then what will happen? First of all, the global mean sea level will be increased, okay, and that will trigger to inundated many of the big cities by the side of the coastal areas. uh, a smaller country, uh, a smaller island countries will be much more affected due to that particular activities. So you can say in each of the area or each of the positions, the global warming or the climate change that has been triggered to create problems for each of the corner of the environment. If not only the inundation but also other things, for example, the salinity itself is a very big problem. When the global climate change started to impact really hardly, then it will cover all the areas where the impact of the sea level can be reached. For example, even your land is there and you are working on the different agricultural activities, then it will not be also possible because of the high amount of the salinity from the ocean. Because ocean current, that means the much of the mean sea level will be raised so that it can inundated more and more areas by the side of the coastal areas, and those areas is not suitable for agriculture particular agriculture. That's why it affected one system, and that will affect another system. So see this figure. This is a figure of the global mean sea level rise, and you can easily understand that there is two pathways that can be seen from the RCP 2.6 and RCP 8.5. So according to the RCP 8.5, that said 8.5 said the total increases will be 6.5 or 0.65, and then the blue color 2.6 RCP, they said around 0.4 meter, okay. And you can also see some shaded portion. Shaded portion means this is the confidence ranges. That means in the RCP 2.6, they say in any way from the 2a from the 0 to increases. So how long it gonna be maximum, and lowest what is the lowest amount of changes can be possible from a particular modeling. So in this modeling, according to the 2.6, it will start it from mean sea level increases of 0.25 or 3, sorry, yes, 2.2 to up to 0.45 maybe. So this is the ranges of the increases of the mean level rise. On the other hand, this is started from 0.04 to 0.04 to 4.5 to up to 1 meter. So all these ways it can be possible. So now the question is, why this is long shaded? Why not it is straightforward on a single line? So we know the model has been based on many statistical conditions, and a statistical condition says if you have this type of things, you will gonna have that type of output. And this might be sometimes very described very differently than it is expected. And so that in some conditions you can say that if this will happen, that will your comeback. In that positions, it will gonna give you a confidence level, so that you can say, well, I can depend on it in how many percentage. So if it is you have high percentage, high dependency on your particular model, and then the shaded area will be reduced. And if you cannot depend on much more them, then it will be reduced, it will gonna give you a big shaded area, so that your idea or your focus will be limited in some of the areas. So now the question is, if our global mean sea level raised up, what would be the condition of the biodiversity? Many aquatic animals that will gonna shift from their places from one place to another due to the changes of the many depthness, physiological responses, and also salinity status. So this is one thing. Another thing is many tree species that will also be changed by the side of the coastal areas. So mangrove is such a good example where the salinity level fix the species differently. I said you maybe in another class, or maybe to the another semester, but that Sundarban is a very unique place, and if the temperature causes the global warming, temperature increasing causes the global warming, and then that will causes the global mean sea level rise, then the salinity will come more inside the Sundarbans, and that time the species composition will be changed, because high amount of the salinity is chosen by the Keura species. On the other hand, low amount of the salinity is chosen by the Sundari trees, and that's why when the salinity increases, then there will be less amount of the Sundari species in Sundarban, and high amount of the Keura species in Sundarban. So species composition will be changed. Agriculture will be impacted. Most of the land by the coastal areas that will be under the water, so that you can only go for the fish farming in there, rather than you cannot use it for agricultural purposes most of the cases. Or even you wanted to use it, then you have to go to find out some saline tolerant species. So everything, the pattern will be changed. Okay. So above all, we can say that due to global warming, our our total coastal areas and wetland system has been disrupted. You can add many examples by your own, but the basic thing is the natural condition of the environmental phenomena has been changed. I think this is all about the impact of global warming on wetlands, and maybe you can also find much more different impacts on different aspects also. But our question is on uh, wetland and coastal areas. So from these understanding, we can describe the global warming in differently, and we can see the impacts in different directions. So now the floor is open. You can ask me anything regarding today's lecture, and this is all about, because it has many wings. I don't want it to go each for each of them. I can only focus on the topics related to your syllabus. So now if you have any question regarding this, you can ask me. Do you have any question? All of you can understand about the anthropogenic causes and the impact of the global warming or climate change.
Sir, can we get more references related to the impact of, sir, biodiversity?
If you wanted to specifically, if you wanted to know, then the best choice is from IPCC report. But
Yes,
if
sir.
you wanted to know in general, then there are many different other publications can be possible to find. But I gave you only the IPCC fifth assessment report, so that you can understand what is the basic process to change. For example, I took all the information here. You can see that is related to global water cycle and coastal areas and others. But if you wanted to know the biodiversity, aquatic, then that is also possible to find out from there. And as it is a global basis, then maybe it is very easy to find out from that report. But if you wanted to know about the regional changes, then you need to find out it more carefully inside the report. And each of the regions has been described different separately in the report. For example, if you wanted to know about the Asian and South Asian countries, then you have to concentrate more different areas of this report.
Okay, sir.
So I wanted to know about the internal force related to land and atmosphere. I didn't understand that part.
Good question. Land and atmospheric interaction, no? So
Yes, sir.
whatever we do describe here, that is most of the cases we are describing about the ocean and the atmospheric interaction, no?
Yes, yes.
So land and atmospheric interaction is one of the example is maybe from this Sahel desert. So Sahel desert has been impacted due to we said impacted due to Atlantic oscillation, multi-decadal oscillation. And Sahel desert itself is very important because Sahel desert is an area which covers a vast area of the land, and that desert is also important due to the other contents because of the feedback mechanisms. So many seasons, it is possible that due to some multi-decadal oscillation, Sahel desert has been impacted. Sahel desert has been impacted because in the dry condition, negative phases, Sahel desert could not get the enough precipitation from there. So actually, it is started from ocean, but now it is a interaction of the atmosphere. And now this, if there is impact of the atmosphere, they also impact on the land surface. So Sahel desert has been impacted less amount of the rainfall during the negative phase of the AMO. So AMO starts from the ocean, but when it causes the impacts, the the different one of the impact is they also causes less amount of the rainfall on the land surface of the Sahel. And then Sahel desert we don't get enough water, and agriculture and everything has been disrupted. So this is one of the example of the atmosphere and land impact. Rather than that, if you wanted any cyclic pattern, then maybe it is might not be very easy to understand, because land surface is not a total in the whole of the earth. Land surface is very less, and most of the cases we have the oceans, and among these among the land surfaces we have many different types of land uses. So there is no vast area where we can get one type of land uses, and that can be go for a particular changes for every time. Maybe it is not possible. That's why we don't actually have any direct impact or energy conversion in land to atmosphere, even though it has been happened, but its duration and the size is very small. Any other question related to climate change or global climate change, even if you have anything in your mind?
Sir, we can think about oceans and other things impacts on climate change, but the land is a little bit unclear to me still.
Sorry, what unclear? Can you just
The land and atmospheric interactions is little unclear to me, because we can think about oceans and other internal atmospheric variabilities, but land, how can it have an impact on climate change?
for example, the precipitation? Okay, so atmospheric precipitation is dependent on the vapor. So vapor is mostly coming from the ocean, that is fast. Okay, so when you once upon a time you take this vapor from the Atlantic Ocean. So Atlantic Ocean, from North Atlantic Ocean to Sahel, it is a long distance area. Okay, so now when the ocean, from the ocean, the atmospheric uh, vapor is taking place, so all the way from Atlantic to long way to Africa, that is going on. Okay, so now it is no more is a oceanic pattern, now it is a pattern of the atmosphere. If that atmospheric pattern now interact with the land, then it is a land and atmospheric interaction. When the precipitation fall from the atmosphere, now this is the interaction between the land to atmosphere, and that has been impacted. Again, from the land, if it don't get enough precipitation, then agriculture, then everything, not only the human activities but also the natural things, for example, any type of forest will not grow there because of the less amount of the precipitation. So that is an interaction between land and atmosphere now.
So
You
I
can
got
you
it.
can say you can say the precipitation is coming from the ocean. Yes, that is true. But this is not started from the Sahel. This is started from long away from North Atlantic, from another couple of 1,000, 2,000 kilometers away. And all the way along that come to the desert area, and they precipitate. But think about the negative impact. The negative phase. At that time, there is no atmospheric phenomena in there. Why? Because maybe the background is there is no oceanic vapor in there, and even in the positive phases, that temperature and precipitation come in here. But now in the Sahel desert, there is no more precipitation because of the less amount of because of the negative phase of the AMO. So AMO actually in between the ocean and atmosphere, but it also react on the land surface. That's all about.
Thank you,
Sorry.
sir.
Sorry, if you have any question, you can ask me. I just make you interrupted.
No, sir, just telling that I understood the part.
Mm. And if you just forget about the internal mechanism, if you just say land atmospheric interaction, there are many examples. But as you wanted to know the internal mechanism, that should be without any influence of the human activities. That's why I am not giving examples of the land use changes or others, because land use change has greater influence on the atmospheric phenomena. but that is human activities, anthropogenic causes. That's why it is not coming inside the internal mechanism. Internal mechanism is rather than little bit natural conditions, and we do say that the energy that has been circulate from one to another, and we say oscillate, that means it come back again in the same pattern. So we don't say this is a change from other side and this is not everlasting, or it is not a continuous to grow, increase, or it will not be gonna decrease. So after every certain years it will come back again. So that's why we say this is a variability inside, and we say internal mechanism. We don't say this is coming from outside. You can say that this internal mechanism can be a part of natural forcing, but it's not, because many cases the natural drivers, they give you the forces, and then they go back. That means you are impacted on that external forcing for a long time. It's not very specific, only a smaller time period, for a long time. For example, solar variability or orbital changes, for a long time it can give you the external forcing impact. On the other hand, internal mechanism, they circulate their energy from one to another, and then again they dissipate to another. Cyclone, for example, they started to grow on the ocean, and then again they fall on the land surfaces, and the energy has been transferred to precipitation. That means the energy which is heated up inside the ocean, in the water, now it has been transferred to change its positions to the land. When the precipitation fall on the land, the energy has been dissipated. So that's why we call, say, that is an internal mechanism between one component to other. And as straight I said, atmospheric phenomena with the ocean, actually it is not so straight. Actually this is a complex matter of fact, but we do describe it differently so that we can understand it.
Sir, there was a thing El Nino. Is that the warm phase and La Nina is the cool phase?
La Nina is the cool phase. Yes, yes, La
Sir,
Nina.
is there any impact of El Nino on desertification?
In desertification,
Yes, sir.
yes, but not here. El Nina and La Nina is mostly related to by the side of the Peru, Ecuador, or that part. So when the precipitation is not happening there, that time there is less amount of the water in there, but not actually you can say directly desert areas in there, because mostly the desert areas is famous desert areas in Africa and some countries of the Asia, but obviously there is less amount of the rainfall in there.
It means it causes some kind of drought
Yes,
in some
yes,
areas.
and mostly agricultural drought.
Thank you, sir.
Yes. Okay, so is there any other question from any other one? Oh, there are two questions in the chat. Sir, what does RCP means? RCP means representative concentration pathways. That means this is a name of the model. Models, there are different models throughout the world. Many people created the models on the basis of different logics. What will be the concentration of the future scenarios? What will be the concentration of the carbon dioxide? What will be the temperature in 2050 or 60? So different models based on different logics. For example, just a good example is if you have 1 minute, please. Yes. Hello. Multi. Okay. So RCP gives us the sum of the logic. So there are many different concentration pathways, For example, if the carbon dioxide is it will be 420, for example, then what will be the temperature? So 420 ppm, then the temperature will be that. If it is much more than that, then what will happen? So depending on many logic, they sets many scenario, and each of the scenario they also presented some of the confidence level so that they can show you the ranges. If this will happen, then the highest level will be that. If that will be not possible, then highest level will be very less. Maybe I can give you example from a general understanding. If you wanted to go by walking from the Ifescu to the 0 point, it needs maybe 15 minutes. But 15 minutes is not fixed. Maybe sometimes it is 14, sometimes it is 16. So some model will say, well, if you are walking, then your time limit will be 10 to 20 minutes. Okay, so this is the shaded area of the model, and RCP give you the idea idea to where uh, it will gonna finally touch. So RCP wanted to give you the idea. If you are very accurate, then your position will be 10 minutes, sorry, 12 minutes. If you are a little bit slow, then it will be 10 minutes. If you are very if you are very slow, then it will be 15 minutes. If you are very fast, then it will be 10 minutes. So RCP give you that idea. Now the question is why. The next question is, another one says, sir, why is there such many models rather than one? Because your logic is different, because you don't know anything very certainly. For example, I can give you idea. uh, Many countries, they wanted to try to sign on the convention of the climate, okay, but many countries, they didn't sign. For example, if tomorrow or in the next day or next year, USA signed the climate protocol or climate convention, then maybe there is a great chance that some of the carbon dioxide concentration will be reduced. Okay, so some models said, okay, in 2030 USA might be ratify or sign the convention, and some models said no, they might not be signed this notification until 2050. So who knows? So depending on many assumptions, I should say assumptions, yes, depending on many assumptions, the model varies, and that's why there are so many models. Which model you are gonna say this model will find, that is depend on you, because you will choose the assumptions. Can you understand it? Why there are so many models? For example, you will say, well, I will definitely get a rickshaw in 4 o'clock from Ifescu to 0 point. And someone said, no, you will not get that. So the model result will be different. So you have to walk and you need 15 minutes. And if you said, yes, I'll get definitely a rickshaw, according to you, your understanding is you needs only 3 minutes to reach to Ifescu to 0 point. That's why there are so many models, because of your assumptions. Because assumptions, it cannot be very perfect. Assumptions is always there is flaws in there, because sometimes we say that will happen, okay, and depending on your result will be different, and we cannot deny any of them. We cannot deny any of them, because if you deny it, that means you are so straightforward about your assumptions, and that might not be possible.
Sir, I have a question.
Yes, please.
So we are a country, a coastal country, so we have issues with oceans, sea level rise. But there are, that's why we are studying these consequences, greenhouse effects, and the anthropogenic ways, and how to control those. But there are countries like United States of America, they have no issues with oceans, or they are
And
more
they
about
have issues, but not like us. They have issues also differently. Yes.
Yes, sir. They're saying, moreover, they're saying that greenhouse effect is a blessing for them because
In
it's
some of the
like,
countries, yes. Yes.
yes, sir. So doesn't this make a difference between them and us, because we are so precautious of in greenhouse effects, but they are not.
Yes, certainly, you're right. That's why they are not ratifying or signed the different convention, because they said they will not have no problem.
They are not also following the industrial protocols made
That's
by
right.
IPCC.
Yes.
Yes, sir.
Yes.
So
Actually,
doesn't this
actually,
make a
actually,
conflict
how
between them and us?
uh, actually how you are explaining it is not so straightforward. Maybe we have problems of coastal areas, but they have different other problems related to climate change. But the problem is, actually, the problem is much more much more complex. I will give you a little bit of idea. For example, India and China, okay, they are the countries who also emits a lot of uh, carbon dioxide into the air. India, China, and Brazil. But but they said we are not stopping this because we are not first world countries. Okay, so the ratification said those first world countries, they should not be allowed further carbon dioxide emission because they are already first world countries. But India and China said, well, that's true, that's fine, we are going to sign it because we can also emit little bit more years because we are not first world countries. And now America said, USA said, well, I'm gonna sign it if those countries will sign it. So what is your demarcation? What is your humanitarian matter here? Should they sign it or should they stop their emission also? China and India?
Yes, sir. They should stop the emission, but
That's why the USA also think that. But the China said no, we're gonna not stop because uh, from 1850 to 1990, you the people who emits all the carbon dioxide, we did not. Okay, so now we are industrialized countries. Now we will emit some, and then all of us will stop. But now you should stop because you have already emit lot of carbon dioxide into the atmosphere. This is the logic of China, India, and Brazil.
sir, that's kind of political conflicts.
Yeah, it's not, yes, political, obviously political, but it is also, yes, that is also true. You see the concentration of the carbon dioxide, that is all of the concentration coming from the first world countries. The China and India now emitting, but before 100 years there are not too much emissions from these areas. So now the concentration 280 to 400, all this concentration is coming from those industrialist countries from 50 years back. So this is, there are many other issues. I just give you one thinking area. So there is another course related to only the climate finance. Okay, that is also very much interesting, and throughout the world it is also been, that is a different issues. Anyway, so we can think differently. There are many issues to think about climate change, and it will gonna last long how many years I don't know, but it's a very interesting topics, and we can see many aspects of the climate changes. Here we are only discussing about the science, but there are many other issues. For example, climate finance, adaptations, mitigations, different things. Okay.
Yes, sir. Thank you.
Okay. Okay. So thank you all. Maybe we have only one chapter left, and in the next class we're gonna finish that. So thank you joining me, and hopefully we'll come back in Tuesday. Thank you all.
Assalamu alaikum, sir.
Assalamualaikum, sir.
Walaikum